I'll go ahead and share my screen. Give me a minute with that. Okay. Before I dive right in, I wanted to ask you all, like, how many of you here are native Android developers or like native iOS developers? So if you can, like, really quickly comment down that you work natively with Android, with iOS, like you use Swift or something like that. That is just a quick question. If you can write it down in the chat. So, today's session we are talking about method channels in Flutter, and again, this is part of the Flutter Forward extended events that are happening with GDSEs. What we are focusing on today is writing custom like platform specific code using Flutter. So here's how we'll go through the session. We'll start out with the Flutter architectural overview. Need to know that just to be sure, like we are all on the same page with how Flutter works, and then we'll move on to platform embedding. How platform embedding is done in Flutter. What are the types of platform channels available? So among these two types of platform channels, one is method channel, which we'll cover. Then we look into calling this platform specific code. Like if you are working on if you are like an Android iOS developer, you want to have some code that is written natively. How do you do that using Flutter? And there will also be a code walkthrough. I wouldn't be writing live code because I've seen generally goes wrong with live sessions. So there would be a code walkthrough instead, and then lastly we'll demo the application and talk about some of the use cases of using platform channels in Flutter. So a little bit about me. I am Aditya Thakur. I currently work as developer advocate at 100ms. So we at 100ms help you integrate live audio video into your applications. And if like need help with that, I would be happy to. And I also make YouTube videos. I have around 8,000 subscribers on YouTube, 1,500 plus developer community on Discord, and I have previously been a speaker at Flutter Vikings Google I/O Extended. Other than that, I contribute to open source projects like the Flutter Community Plus plugins and the Flutter Fire repositories. So quickly looking at the Flutter architecture, Flutter is this cross-platform UI toolkit, and we have like you might have had it covered in a few of the previous sessions. So it is designed in such a way that it would allow you to reuse code, like have the same code base and build applications for both Android and iOS. Uh, the major advantage again is if you are a startup, if you like are working on a startups, you do not have to separately hire two teams of developers to work on the same project. You could have like a Flutter team to build it out. So the goal again is to have developers deliver these high performing applications. They have the native experience. It should feel very natural to use on the operating system that they are on. So like if you're building an Android app, you would have some like Android specific things that you want to do. On iOS you might want to do it differently. So what happens with Flutter is during development, Flutter apps run in a virtual machine. So you can use features such as hot reload without having to recompile your applications. But when you do a Flutter release, so when you're building an application for release, these Flutter apps are directly compiled to machine code. So depending on the machine or the operating system that you're trying to cater to, these are directly compiled to this machine code. So it could be like an Intel x64 or ARM, or to JavaScript if you are like targeting web, and that is how it works. A brief look at the Flutter architecture again. We have our the first one we are talking about is embedder, which is platform specific. So this platform specific embedder is our entry point. It coordinates with the underlying operating system that we have to access a lot of services there, like accessibility and rendering something on screen, and the message event loop. So this is the first one. The second in line is the engine. uh, this engine or the Flutter engine is, the main component or the core component, and it's mostly written in C++. So what it does is it supports all the primitives necessary to build out these Flutter applications that we talk about. And lastly, as developers, we interact with the upper framework, which is like the framework that we build out applications in. It provides us access to all these widgets that we can use, and it's like a modern reactive framework written in this in the Dart language that we are familiar with. So if if Flutter is cross platform, how can it offer this performance that is comparable to like comparable to single platform frameworks? That is like the major question that we get. If you are working on more than one platform, how can you have like a performance that is comparable to what Java or Kotlin would feel, or Android, or Swift on iOS? So cross-platform frameworks, what they generally do is they create an abstraction layer over this native Android and iOS, and like everything that all this adds is like a significant overhead, which is a lot of interaction between UI and the app logic. By contrast, Flutter reduces those by passing the system UI widgets in favor of its own widget set. What this means is Flutter has its own widgets instead of using the platform specific widgets. Flutter provides some of its own options as widgets to use, and you like whenever we are building application, we use those widgets to do that. So a little bit more about it. Okay, so Flutter provides these set of widgets, like including the material design widgets that we are familiar with, and the Cupertino iOS styled widgets, which are managed by the Flutter framework and engine. And again, if you have like attended a session, like introductory session, you might be aware like there is a whole flutter.dev dash widgets catalog where you can find these widgets to use. And this like these widgets can be then later on compiled to the machine code. So these Flutter user interfaces are built and completely laid out, painted by Flutter itself. So whenever you are building an application, everything that you see on screen is laid out and painted by Flutter, rather than being translated into what an operating system specific widget would look like. So if you are on Android, iOS, irrespective of that, you'll have like the widgets looking almost similar across platforms. And when you start a Flutter app, the embedder, which we talked about previously, provide this starting point, which initializes Flutter engines, obtains thread for the user interface, and creates that texture that Flutter can write to. So everything then would be written by Flutter using Flutter's own widgets. And again, each platform has its own APIs. They have their own constraints. Like on iOS and macOS, if you have like looked into the platform specific code, whenever you're building a project, there are different directories created. Like there's Android, iOS. If you go down to the Android, you'll see like on Android, Flutter is loaded into this embedder as an activity. So if I go back to my code here, under Android, if I go to main Java main activity, you'll see like there is something called Flutter activity here. And so the view is controlled by the Flutter view, which renders everything Flutter related inside it, depending on like whatever specifications you have. And for mobile and desktop apps, for mobile and desktop apps, Flutter allows you to call like some of the custom code through something called a platform channel, which is used to communicate between the Dart code you have and the platform specific code of your host application. By creating this common channel, you can send and receive messages. So you have your Dart code, it can interact with the native side code, like a component written in Kotlin or Swift, and it would send out like is you can send out data in a map format and then get back some reply equivalent representation, such as in Kotlin, we have something called hash maps. In Swift, we have dictionary. So in that way. And again, this is like the diagram of how it works. Have our custom Dart code. We have the method channels interacting with the Android code. So method channel here also, and they can be used to interact with both Android and iOS side of things. Again, this is like a lot of information to take in. What we talked about was first Flutter architecture overview, second how it renders it. So we don't use the platform specific OS widgets. Instead, Flutter uses the embedder to create uh, platform specific like the screen where it would lay out its own widgets. And then lastly, the last part was platform embedding, which is something that we'll look forward into. So why are we again talking about this? Let us imagine like a common use case where you are asked by a client to integrate like a third party provider. Now this provider might not have like a Flutter SDK or something that supports Flutter, but they have like iOS and Android SDK. So in such cases, you need to call these SDKs from Flutter. One example of this is the TensorFlow Lite. So if I just copy this and paste it here, you'll notice like on their website they don't have anything like called Flutter SDK. Although there are packages available in Flutter to use, but they have like Android and iOS here. So if you were asked like, okay, I want to do like something with TF Lite in my Flutter app, you might have to go on the Android side because some of the packages available too are a bit outdated. So there could be a lot of other things that might might not have like the Flutter SDK, or that does not support Flutter as such. So that is where like platform embedding or talking about method channels becomes important. Now, depending on the platform, there are some languages that are used in Flutter. So on iOS, we have Swift or Objective C. On Android, we can either use Kotlin or Java. On Mac OS, we again have Swift or Objective C, Windows C++, and Linux C programming. There are two types of these method channels, two types of, sorry, platform channels. One, again, method channels. This you can think of like a future. So it is used to communicate with the platform using like a asynchronous method call. And two, there is event channel, where you can listen to event streams from the platform. Like you'll get a whole stream. You can listen to it for any changes that might happen. And a little bit of the architectural overview of this. So messages are passed between the client UI and the host platform. So in a Flutter application that is running on Android, like the Android app, the host platform would be the Android operating system, and a name channel is used for communicating with the platform plugins. So this is again an asynchronous process. So you'll call on this method, you'll wait for it to send over a response, and until then the UI is not disturbed. So you can wait for it, and when you get data, you can update the UI depending on the response. On the client side, method channels enable you to send message that correspond to these method calls. On the platform side, these method channels and Flutter method channel on iOS enable you receive these method calls and send back a result. So again, a lot of text or like verbal info. So we'll take this to code now. What we'll try to do is build out something that helps us get the battery information. So this is like a native Android side implementation. So you can run a command like whenever you are creating a new project, you can run Flutter create battery level, or the name of the project that you're working on. By default, this enables Kotlin on Android and I think Swift on iOS. If you want to like not do that, and if you want to create a project, if you're familiar with Java, you can instead run the command Flutter create dash I Objective C. So this would enable Objective C as the language for your, like, for iOS side of things, and dash a for like for Android, to enable Java as the language. And again, with calling platform specific code, there are a few steps involved. So we start off like by creating a new app project. We can then create like a Flutter platform client, and then add like Android specific implementation, iOS specific implementation, and then like Windows or Linux platform specific implementation. So this is like a new Flutter project. Since I wasn't doing like live coding, because a lot of the times it goes wrong, so I had something, something built up for reference. The first step while building, a platform specific implementation is to import the Flutter services.dart. And we need this to, to be able to access these platform services. And we'll start off with, this is the main.dart file, so we'll need a main function here. And this main function, what it does is it simply runs up a material app which has like a platform channel widget set as the created this. We can start off by creating a stateful widget. Stateful, why? Because, since this is an asynchronous call, so we'll update once we have the data from it. So we can create like two local properties. One is battery level, and then charging status. We can initialize them as battery level unknown, or battery status unknown. And then to create like a method channel, what we can do is add uh, we can create a method channel, something like this. So method channel comes from this method channel class, which is like a name channel for communicating with these platform plugins using, again, asynchronous method calls. And whatever name that you keep here should be the same value on your platform side. So we'll also look into that. And we can also create like an event channel. So if we are trying to get the battery level info, so this is how, you can use the event channel class to create an event channel there. And again, we can create a function which would help us get the battery level. It would have like a local property battery level, and they'll we include like a try and catch, just to make sure like if there is an exception, we are able to catch it. And inside this try, what we'll do is we'll use this method channel and invoke the method called get battery level. On the platform side, like if you're working on Android, we'll have to create this function there to get the battery level and set the local property that we have created to the result that we have here. So this result would be set there. Again, if there is an error, in getting the battery, we can set this local variable battery level to no battery, or to like a appropriate error message there. And once we find out what the battery level is, we can set state to also show this battery level to our end user. And we'll add a init state to initialize this event channel that we had created to listen to the events, and if there is an error, so both on event we can show the battery status, and if there is an error with it, we can show like battery status unknown. So lastly, all we have to do is build out the build function of our application. So this is again inside material, we create two columns. uh, the first column would show the battery level label. It would have like a button to refresh it. And again, we'll add like the charging status of what our mobile app is on. So that should do it. Like that should be enough for the Flutter side of things. Again, to reiterate, like we have created this method channel here and event channel down here. The name that you put in here should be same. Like when you're working on the platform side, this should be similar. And we have created a function that simply gets this value and updates the state. We use the init state for listening to the event channel stream, and lastly we have updated our UI on the material side to show whatever value we get. On the Android side, the implementation would again go inside this main activity, which extends this Flutter activity. So you can change the configure Flutter engine function that is here uh, with with like this on listen. So and like this intent, like you can add this register receiver here, so which would notify of this state change. And we'll create a new method channel here, which what it does is basically, if the call that we are doing is get battery level. So if you come back to your main.dart, you see like the method channel being called here, invoke method, we give it the get battery level, and the same again we have to define here. And depending on like we have also have some local imports here. So these are some of the local imports that we have done to get the battery level of the mobile device as it would on a native code. That is why, like, I was asking if there are any native developers here, so they would have been like been better able to understand this. We have to make some native imports also to get the battery level, so that would remain similar. uh, Inside this method channel we just tell it like if the call that is being made equal to a particular string value that we have here, it's similar to the one being called, then we'll run some code, and we can send out a result with success or error depending on whatever it is. So this is like the private function that is created here to get this battery level, and all it does is gets the battery level from the Android side and sends it back to Flutter. Again, these battery channel and charging channel strings need to be similar to what you have created here in main.dart, and we can quickly see this in action on our Android. Like if I connect my Android device to it, I can see this in action there. I'll quickly do that. Let's run this application once. So if I have my Android device configured, I can go back to main.dart and wait for this application to launch. So this is it. This is what it builds to. So right now it's showing battery level unknown because the status is set to charging. Since I have like my mobile device plugged in, this status is charging right now. But if I disconnect it here and if I refresh it, so it will show the battery percentage. I don't know if it's visible using my camera. So it's saying like battery level right now is 41%, and the status changes to discharging. So this is like one way of using uh, these method channels inside your Flutter application. So again, this was only the Android side implementation. There is a whole documentation page available on how you can set it up for iOS as well. The only thing that you need is if you are running this application on an emulator, like if you run the same application on emulator on Android, you can set the battery level for your emulator, but on iOS you'll need a real device to do this, because otherwise you wouldn't be able to get uh, the battery level there. So for the iOS platform, you can, if you have like created a Swift, if you have created a normal project, again the process would be similar. You'll have to open up the project in Xcode. There, like modify the app delegate uh, by going down to runner and again runner there, and you'll find the app delegate there, and add some code there, which is in like Swift, to get. And they, again, you'll see like they have this receive battery level function, which would uh, get the battery level from the device and send it back to this Flutter app delegate here, and it can modify this method called handler, which will return the result back to the Flutter app. Similarly, we can also do a Windows platform specific implementation. So if you are working on a Windows application, you can add code by going down to you can add the C++ implementation by going down to the project folder source files, and there you'll find like flutter window.cpp, and there you can add the code, something like this. So I'll also drop this link in chat if you need it for later on. And then we have like a Linux platform specific implementation, which would require you to do some changes in C programming, and that would be it. So again, like talking about this example itself, like if you were working on Android, if you, like, let us say you are trying to implement like TF Lite in your Flutter application but using Android, so you can go down to their documentation, like the quick start itself. So however, like the steps are involved here, you can almost do similar things, like add the dependencies there inside your Android project, and then like initialize TF Lite and model interpreter. And if you look at any of the existing packages, like if I go here and find TF Lite, the TF Lite Flutter, and go over to its repository of the package, you'll see like inside lib, let's go down to, not this one, TF Lite package. If I go down to their repository, you'll see like inside this package also they are just using method channels. So this is again like they have created a method channel here, which is load model, and it just invokes these method called load model. And again, if you go down to the Android side of it, uh, under source main and in TF Lite, we should have this tflite plugin.java with a lot of like the method channels created here. So this has the similar code on method channel, and you can load model here, uh, do a lot of other things like detect object on image and pass back the result. So this is like a very big file. So these are like all method channels that Flutter is then calling them, and that way you can integrate TF Lite also inside your Flutter applications. So again, a lot of things to catch on. This code part could be a bit difficult to first make sense of, but the simple thing that we are doing is we are creating these method channels that are then running platform specific code, which is very simple if you think about it. And what about web? So we talked about mobile and desktop, but what about web? So Dart is compiled to JavaScript on web, and since the like the Dart and JS are have interoperability, so it is possible for you to run like JS functions directly using this package JS, and that way you can run platform specific code for web using Dart there. And other use cases of this, like the one was the TF Lite one example. What are some of the other use cases that you can look into? One is biometric authentication. So again, there is a blog piece linked here. So if you go over to Flutter native APIs, this is a blog by my, like this is by a GD, Flutter GD. So what it covers is like how can you do like native authentication using by using like native side code in Flutter. So again, this has the Flutter side of things, how do you create a UI there, but it also has the method channel part. So it has like both iOS specific and Android specific method channels. So on iOS, like we work with Xcode to make those changes. On Android, we'll use like Android Studio, and then you can, test these out by the code that is written here. So this is also something to try out. And lastly, to call any platform specific code using these like channels, you do not have to necessarily write all this code on your own. Like there are a lot of packages available out there that could help you do this. A quick difference between packages and plugins. So packages are generally written in Dart programming language. A plugin package is like a special kind of package that what it does is it takes makes this platform functionality available on the app. So it can be specifically written for Android using Kotlin or Java, for iOS using Swift or Objective C, and you can have that platform specific implementation. So again, if you go over to pub.dev, you'll find a lot of packages and plugins that let you do for the same battery example that we talked about. You can find a package here. One good package is the Battery Plus. So this is by the Flutter community, and it also does both of those things. Like you do not have to write the platform specific code. You can just copy this package from here and take it to your Flutter app and use it there to get like the battery level and even the charging if it's like plugged in or charging or not. Similarly, there is URL launcher package, which I just wanted to highlight here. So URL launcher, it also supports web, like it also supports phone here. So you can make a phone call to a number using the default Flutter app. So if you're on Android, you want to make call to someone, you can use this URL launcher package. Also send an SMS, so it will open up whatever default messaging app you have, and it will have that text, and you can send that SMS really quickly. So this is also another good package to look into. And lastly, I think that would be it. So this is like my first time talking about platform channels, so I didn't get to time my talk. If you have any questions, like I would be happy to take them. Even if I'm not able to answer them, I will like look into it and get back to you on that. Again, you can like reach out to me on Twitter, Aditya Thakur XD. Maybe connect with me on like join our Discord community where we have like 1,500 plus members talking about Flutter. And even after this session, if you run into something, you can always ask there. So if you want to do that, take a quick screenshot of this slide and you can scan this QR code to hop into our Discord. And thank you so much. Like that was it for this session on like platform specific code in Flutter. Thank you.
Yeah. So, everyone, do you have any question or anything?
Yeah, hi.
Hello.
Yeah.
Hi, Aditya. So I have a question that when we were calling to
Mhm.
the method, okay, we were only giving the
Yeah.
function name. So is there a way we can pass some data to that Java code from the Dart file, like giving a parameter?
I haven't looked into it, but I don't think like you can pass it. Like you can have a result back, but let me get back on this one if possible. Uh, I have to look into that.
Actually, I had one more question. It's
Mhm.
actually a little bit off the topic, but
Yeah.
I wanted to ask you that which state management do you prefer?
This is a common question.
Actually, it's
Yeah.
anyway, it's very confusing.
I personally prefer Riverpod. and I am very occasionally vocal about that because if you look at any other state management that is available to you, uh, particularly block has a, block is used by a lot of companies out
Yeah.
there. So generally whenever you're starting out, everybody tells you like use block. Block is the best, but generally block has a lot of boilerplate code that you have to
Hmm.
write. That is why I prefer Riverpod for like my personal projects. I don't use GetX. That is only because GetX tries to do a lot of things. It is very easy to use because a lot of beginners start out with it,
Yeah.
but GetX like has navigation and everything, and it tries to do a lot of things, and then you get confused. So I don't recommend that either. Uh, like provider is good starting point. Then move to Riverpod maybe if you are like into that.
Actually started with GetX, but a
Hmm.
few people told me to avoid using GetX. So wanted to ask the same question: why people are saying to avoid GetX?
There is, I think, a few general reasons that I know why people generally do like say avoid GetX
Yeah.
uh, is one is they don't have the trust in the package maintainer. So often it's said like the package maintainer might abandon GetX, and you wouldn't like all your apps that use it, so they'll generally run out of support. Second is there were a few, like this is from a Reddit thread I read once. So there were a few rumors like the package maintainer had copied some code and then he had used it without like attributing it to the real authors. So that is why there is like journal hate in the community. But
Okay.
a lot of like freshers, a lot of people who start out with Flutter, their first choice is GetX. I know a lot of people who use GetX. So it's totally up to you. If you like it, it's like you can stick to it. There is no problem as such.
Thank you.
Awesome. I'll look into that. I don't know if you can pass it or not, but I'll have to look.
Yeah, okay.
Mm.
You can I'll search for it now.
Okay, so any other questions? Anyone? Yes, Mano, bolo.
No, that was by mistake.
Acha, okay. Yeah. So anyone else? If there is no question, then we are good to conclude this session.
Yeah.
Yeah. Okay. Like considering others don't have questions. Yeah. So thank you, Aditya sir, for having a session with us. Okay, for us from the community, and we are looking forward to have more sessions like this.
Yeah. Thank you, Aditya sir, so much.
Thank
Thank
you.
you so much.
Thank you so much for having me. I'm really sorry this finished out fast because I hadn't timed it uh, today. So, but
No,
anyways, really
we
glad.
learned a lot. It was really new platform channel thing. It was
Yeah,
great.
even for me, like so. But anyways,
Yeah.
thank you so much. Bye.
Thank
Yeah.
you.
Thank you. Bye, everyone.